Think about how you give directions of your house to a friend. You usually say something like, take a left at the park and it's the third building on the right. But what if you are stuck in the middle of the massive Pacific Ocean or flying a plane through an empty sky? How do you point to an exact spot on a giant spinning planet? To solve this, humans had to wrap the entire world in a giant invisible grid. But before we look at that grid, we need to clear up a massive myth. The Earth is not a perfect round basketball. Because our planet is constantly spinning at a mind blowing speed, the rotation actually forces the middle to stretch out. The Earth is a bit chubby at the equator and slightly squished or flattened at the north and south poles. In fact, if you measured the Earth from side to side at the equator, it is 22 kilometers wider than if you measured it from top to bottom. Because of this irregular shape, identifying a location is a nightmare without a reference system. That is why we invented latitudes and longitudes. Let's start with latitudes. Imagine taking a bunch of horizontal hula hoops and stacking them around the Earth. The absolute biggest hula hoop sits right around the dead center of the planet. This is the equator, and we slice it at 0 degrees. The equator acts like a giant knife, cutting the world into two equal halves, the northern hemisphere and the southern hemisphere. As you go north or south from the equator, the hula hoops get progressively smaller and smaller until they shrink into tiny points at the 90-degree North Pole and the 90-degree South Pole. Every single degree of latitude is separated by about 110 kilometers of land. If a line is north of the equator, we mark it with an N, and if it's south, we give it an S. Within these lines, there are four major celebrity latitudes you absolutely must know. The Tropic of Cancer at 23.5 degrees north, the Tropic of Capricorn at 23.5 degrees south, the Arctic Circle at 66.5 degrees north, and the Antarctic Circle at 66.5 degrees south. These four lines are incredibly important because they act as the boundaries for the Earth's heat zones. The area trapped right in the middle between the Tropic of Cancer and the Tropic of Capricorn is the torrid zone. Because it faces the sun dead on, the midday sun shines exactly overhead at least once a year, making this zone an absolute furnace that receives the maximum amount of heat. Move past the tropics toward the poles and you enter the temperate zones. Here, the sun's rays hit the curved surface at an angle, spreading the heat out. The sun never shines directly overhead here, giving these regions mild, moderate temperatures. Finally, pass the Arctic or Antarctic circles and you hit the frigid zones. In these regions, the sun barely even rises above the horizon, keeping the land locked in a permanent freezing dark winter. Now, those horizontal hoops help us map the world from north to south. But we still need to map it from east to west. This is where longitudes step onto the stage. Instead of horizontal hula hoops, imagine slicing an orange into vertical wedges from top to bottom. These vertical lines are called meridians. Unlike latitudes, which get smaller near the poles, every single meridian is a semicircle of the exact same length, stretching from the North Pole to the South Pole. The distance between them is widest at the equator and shrinks down to zero at the poles where all the lines tightly meet. To start counting, we needed a 0-degree baseline. In 1884, the world agreed that the starting vertical line would pass right through the British Royal Observatory in Greenwich, London. We call this the prime meridian. From this line, we count 180 degrees eastward and 180 degrees westward, splitting the Earth into the eastern and western hemispheres. Interestingly, the 180-degree east line and 180-degree west line are the exact same line on the back of the globe. But these vertical lines don't just tell us where we are, they literally control the watch on your wrist. Because the Earth rotates from west to east, different parts of the planet hit the sunlight at different times. When the sun is at its absolute highest point over the prime meridian in London, it is exactly midday or noon for everyone on that line. Since the Earth takes 24 hours to complete a full 360-degree rotation, we can do some simple math. 360 degrees divided by 24 hours means the Earth rotates exactly 15 degrees every single hour. Break that down further, and it moves 1 degree every 4 minutes. Because of this, places to the east of London see the sun first, so their time is ahead. Places to the west see it later, so their time is behind. If you move 15 degrees east of London, you're exactly 1 hour ahead of London time. If you move 15 degrees west, you are 1 hour behind. This creates a massive problem. If every single city used its own local meridian to set its clocks, train schedules and business would be in complete chaos. Every town would have a different time. To fix this, countries established a standard time. In India, we chose the meridian of 82.5 degrees east to be our anchor line. The local time on this exact line is what we call Indian Standard Time, IST, and it applies to the entire country. Because India sits well to the east of London, our clocks are exactly 5 hours and 30 minutes ahead of Greenwich Mean Time. So when it is 2 p.m. in London and people there are just finishing their lunch, it is already 7:30 p.m. in India and we are getting ready for dinner. And that is the incredible system of latitudes and longitudes. They aren't just boring numbers and lines in a geography textbook. They are a brilliant worldwide network. A system that lets a pilot find a tiny island in a vast ocean, divides our planet into tropical and frozen zones, and synchronizes the clocks of billions of people so the modern world can run on time.